Uh, my name is Mohit Bijoria. My registration number is URK24CS1080. Data success and algorithm 23CS2012. So like uh, I'm going to show experiment number 4, which is array implementation of circular queue. So a circular queue is a type of queue that connects the end back to the front, which forms a which forms a circle. So it follows FIFO principle, where the element inserted first is removed first. Unlike a linear queue, the circular queue efficiently uses memory space by reusing the freed positions after the removal of the elements. So in this program, the init function method initializes the circular queue by setting the front and rear pointers to -1, then defining the maximum size of the queue and creating an empty list to store elements. This full function checks whether the queue is full by verifying if the next position of the rear equals front. Considering the circular nature of the queue, then isEmpty function checks if the queue has no elements by testing whether front is -1 or not. And then the enqueue function is used to insert an element into the queue. It first checks for the overflow using isFull function and then places the new element at the correct position while updating the rear pointer. And then the dequeue function removes an element from the front of the queue, and if the queue becomes empty after the deletion, both front and rear are reset to -1. And then at last, the view function displays all elements currently present in the queue in a proper order, starting from the front to rear, even when the queue wraps around circularly. Finally, in the main program, the user specifies the size of the queue and performs a series of enqueue and dequeue operations to demonstrate overflow, underflow, and the circular behavior of the queue. And when we run the program, it first checks for underflow, and then after inserting elements up to the maximum size, we get a queue overflow message when we try to insert one more. After removing a few elements and adding new ones, the circular queue shows that it reuses the free spaces efficiently. So some real-life applications where circular queues are widely used are operating systems for managing processes in a round-robin scheduling manner, and embedded systems like printers where print jobs are managed in a circular queue, multimedia systems for streaming audio-video buffers. So now I'll show you the output. I'll enter the size of the queue as 3, and then the values of the queue. So after many operations of NQ and DQ, finally it shows the present queue content. So at last this experiment demonstrates how a circular queue efficiently manages a data in a cyclic order without wasting memory space.